For our first example, we will create a table called cust_California to hold our list of customers from California. And we will create this table by defining a create statement with corresponding field names, value types, and appropriate keys. For our unique primary key, we will use the values of customer ID, address ID, and city ID, which will uniquely identify our row of customer address information. In addition, I will also specify 3 foreign keys using the values of customer ID, address ID, and city ID respectively, in the event that we want to reference the corresponding tables, customer, address, and city at a later stage with our queries. As we are creating this table for analysis, and it is not intended as part of our core production tables, I will not specify any constraints on these tables. But if we were to place this table into production, we could specify constraints for cascading updates related to corresponding tables such as customer, address, and city. For example, if the address ID for a customer was to change, we could have a cascading update from the address table to our table customer California, which would update the corresponding address ID. Such constraints are typically added into tables by database administrators, which as a business analyst, you're not likely to be defining core system tables within a data warehouse. However, it is good to know that such a constraint can be added to a table, which means a database administrator or an analyst doesn't have to identify all corresponding tables that need to be updated if a change is made, and can go ahead and create such constraints to perform the required updates automatically in the event that a customer's details have changed and are required to be changed in other existing tables. We can go ahead and run the statement and check that our table has been created by refreshing the schema for our sales database. We can see that the table has been successfully created, and can also go ahead and inspect the table by clicking on the information icon next to the table. We can select indexes to check that our indexes have been set up correctly, and we can also click on the DDL tab specifically to see the SQL create statement for the table. Note that if you have not specified a default value to MySQL, then MySQL will insert the default values where required, such as at the end of our create statement we can see the default engine INODB specified and character set for Unicode UTF-8. Next we can go ahead and populate our customer California table by using an insert select statement. Note that I have also specified the column names for our insert, which also identifies the order of fields which we will select our data from. If our select statement did not match the order that we have specified, or we had more columns than required, then MySQL will throw back an error. It is not necessary to specify the number of columns or the order of columns, but I would recommend for good practice that you specify the columns and order if you are planning to put your script into production. This will safeguard any future changes to your query and help other developers understand what you intended to insert into your table in the first place. We can go ahead now and run our insert select query to populate our table. To view our results within the table Customer California, we can click on the table icon, which will run a select star from Customer California, implying all records to be displayed. We can see that our result set returned 9 records in total. However, if our table was relatively large and we didn't want to actually bring back the table results, we could perform a number of different queries on the table to identify how many rows have been populated. The first would be to perform a select count from our table to identify the number of rows. For this, we can execute the command select count star from Cust California, and we can see that the row count brought back is 9 rows. In addition, there are a number of built-in functions within MySQL that allow us to query the status of tables. As we are using the sales database, we can go ahead and just execute the command show table status. And this will bring back details of all tables within the sales database. As we only have one table created within the sales database, we only see one row. However, we can change which database to review, and for example, if we wanted to bring back the status of all tables within the Sacula database, we can run the command show table status from Sacula. If we so required to further refine our query, we can additionally add a where clause where we can, like a select statement, provide a column name and a criteria against that column. For example, where name equals customer. Or we can also apply fuzzy logic and bring back tables where name is like cust and provide the wildcard character at the end of cust to imply any table names beginning with cust followed by anything. So as you can see, there are a number of ways in MySQL that we can bring back details about a table from any given database. Moving on to our second example, we will recreate the same table, Customer California, but this time we will use our create table as statement, which allows us to create a table based on a select query. When performing quick analysis, this will be my preferred method, as I do not need to specify individual columns and their corresponding types, as these will be identified based on our select query. Let's first go ahead and drop our existing Customer California table, and we can see that on the left in our sales database that the table has disappeared. We can go ahead now and run our query to create our table, Cust California, followed by our select query for customers from California, and when we run this, the table will be generated and populated with our 9 customers as expected. We can go ahead and inspect the table again by clicking on the information icon. This time, however, if we look at the index tab, we can see that no indexes have been specified for our table. An alternative in MySQL Workbench for creating an index or key for a table is to use the interface provided on the Indexes tab. From here I can control-click and select the columns that we require for our primary key, such as Customer ID, Address ID, and City ID. I can then click on the Create Index button, which will open up the Index Properties panel, where I can specify additional criteria for our primary key, such as if the key is to be unique. I can also go ahead and add a comment or metadata to our index. I will keep the defaults for the sort algorithm and locking. Finally, I will shorten the name of the primary key. And then go ahead and create the key. I can see that the key has been successfully created. And to refresh the DDL tab, I will need to close the information panel and reopen it if I want to see the new updated DDL for our Customer California table, which I can now see as our unique primary key and our corresponding comment that we specified. To demonstrate the manual way to add an index to our table, I will go ahead now and drop the index we just created using the drop button on the Indexes tab. And as I click on the button, it will also confirm by showing me the SQL code that it is going to use to drop the index statement. I can select the drop button to go ahead and execute the command. As our Customer California table already exists, we will use a slightly different syntax to add an index to an already existing table, which is to use the command alter table. Alter table has many functions, and it is worth reviewing the MySQL documentation to identify all the uses of the alter function. For now, I will use the alter table function to add appropriate keys to our Customer California table. I can go ahead and execute the 4 statements I've prepared, and then check the details of our table by selecting on the information icon once again. I can see that the indexes have been created correctly on the Indexes tab, and also on the DDL tab, I can see the corresponding create statement. Note that this create statement does not reflect our create table as statement. That is, it doesn't show the select statement and only shows the create part of our statement. In addition to showing how we can inspect a table using MySQL Workbench with the information icon, if we are not programming our SQL in MySQL Workbench, then it is good to recall the various show commands in MySQL to allow us to inspect a table's DDL create statement and indexes. By highlighting the show statement, we can see a full list of substatements that can be paired with show, such as show create to show a table DDL create statement, or show index to show a table's list of indexes. Let's go ahead and run the create table cust California. The resulting output provides us with 2 columns, the first being the table name and the second with the create table statement. Hovering over the create table statement will expand the statement, but in our scenario, the create statement is too large to fully display and is clipped. We can go ahead and click on the wrap text icon to display the full create statement, and you will also need to then click on the create statement to reveal the full statement. In addition, we can also change to the form view in MySQL Workbench by clicking on the form icon in the results pane. This will provide us with a more legible format for reading from. From here, if required, we could also export the create statement to a notepad, or if we wanted to set up a similar table but with slight variations, we could copy the full create statement for the cust California table and use this to set up a new table. For example, we might want to run a similar campaign in the Florida region, and we could use the exact same structure as the cust California table and only need change the name of the table during our create. Next, we can go ahead and run a show index for our cust California table. I can go ahead and run this statement, and as you can see, it's returned an error. Reviewing the help for show index, I can see that I have the option to use from or in table, and I can go ahead and correct my statement to use the show index from cust California and run the statement again. The first 3 rows you can see is my unique primary key, where the unique value is set to 0, and the corresponding rows reflect my foreign keys that we have set up. At any time, if I'm not using MySQL Workbench for SQL coding, I still have the option to display help for any SQL statement within MySQL by executing the command help, followed by the SQL keyword wrapped in single quotes. For example, I can type help and look up the show command wrapped in single quotes, and this will return the same output as if I'd executed the command in MySQL Workbench. This can be very useful if we don't have direct access to MySQL Workbench, or we are working in the MySQL command line. If we are executing such a command in the MySQL command line, then I will want to follow my statement with a \G to wrap rows of text. I will go ahead and execute help for the show command, and as before, I will also want to wrap the text in the result window to show the full extent of the help for the show command. In addition to changing to the form view, which we saw in our last example, I also have the option to right-click on the value and open the results in a separate viewer window. For another example, I can also run help for a specific SQL statement, such as I could run help for a create statement, but as there are a number of options for create, I can specifically request for help create table statement, where I place the term create table between single quotes. This will now run help on the specific create table statement as opposed to bringing back just help for create and all the substatements that create can be paired with. Once again, I can right-click on the result and open the specific row in a separate viewer window. That's all for this section, and in the next section we will continue with our sales project analysis.